Today we are going to be talking about the differences between a chemical and a physical change, and we're also going to help to identify when a chemical change has occurred. So let's start by talking about what a physical change is, and so that we can understand the difference. A physical change, the substance involved is going to remain the same, even if it changes shape, size, or state. So what this means is the particles themselves are actually going to remain the same, but it might look different. It might be a different shape, a different size, or it could go to a different state. So example, from a solid to a liquid. This means that changes in state are considered to be physical changes. So students often think that by going from a solid to a gas, you're changing the particles. You're not, you're just changing the amount of energy. So it is considered to be a physical change. One way to tell if something's a physical change, you want to think about if it's reversible. So not always, but oftentimes physical change are easily reversible. So for example, when something goes from a solid to a liquid, you could always change it back from a liquid to a solid. Even something as simple as dissolving sugar in water, this is considered to be a physical change because you can always boil away the water and you'll be left with the sugar. Chemical changes, on the other hand, are when you form a new substance. So it's when the particles actually change their composition. They actually reform to form something new. Chemical changes are not easily reversible. Some clues that we might want to look for to decide if there's a chemical change. These are always the signs of a chemical change. These are actually really important to understand because you're going to use these all the way up to grade 12 to see if a new substance has been formed. So if a new color appears, then it's considered to be a chemical change. This is an unexpected color you didn't think that you were going to see. It's not the same as dyeing something another color. If heat or light is given off, that's an example of a chemical change. If bubbles or gas form, chemical change. If a solid material is formed. So what this means is you have two liquids, you mix those two liquids together and you get a solid. That solid is called a precipitate. That's an example of a chemical change. Or if you have a new odor form, that's said to be a chemical change as well too. Let's talk a little bit about energy. So we mentioned energy last time when we talked about states of matter. We said that you can add energy in to go up a state of matter. You can take energy away to go down a state of matter. In a physical change, the original substance still exists. It just changed form. Energy changes do not typically accompany physical changes, except in phase changes when the substance or when a substance dissolves. So what this means is that if I go through and have a physical change, I don't typically see a change in energy. I don't see heat given off. I don't see heat going in. The only exceptions to that are when there's a phase change, so going from a different state, or when substances dissolve, you often see an energy change as well too. In a chemical change, a new substance is produced. Energy changes always accompany chemical changes. So whenever you have a chemical change, and you know you have a chemical change, if you have one of those signs of a chemical change we just went over, you are going to see an energy change either given off or energy absorbed. Chemical changes are always accompanied by physical changes. So if you have had a chemical change, you also will have new physical changes because you've created a new substance. Okay, so we're going to practice this a little bit. We are going to look at a list of changes and we're going to try to identify whether or not it's a chemical or a physical change. So you either want to look for the signs of a chemical change or you want to think about, is this reversible, yes or no? If it's reversible, it's going to be a physical change. If it's not reversible, it's going to be a chemical change. So take a look. Sodium hydroxide dissolving in water. So sodium hydroxide is like a little clear pellet dissolving in water. You want to think about, is this a chemical or is this a physical change? So pause the video, take a second. Before we go to our next example, sodium hydroxide dissolving in water. This is an example of a physical change. Anytime you see the word dissolve, dissolving is actually always a physical change. Even though there might be an energy change associated with it, dissolving always means physical. Hydrochloric acid reacting with sodium hydroxide to produce salts, water, and heat. So here we have an acid and we have sodium hydroxide, a base, reacting together, and it's producing salt, water, and heat. Is this a chemical change or a physical change? In this case, this would be a chemical change. How do we know? Well, we actually produce new substances, salt, water, and heat. And our sign of a chemical change was heat was given off. If there's any sort of heat given off or heat absorbed, then it's an example of a chemical change. Water is heated and changed to steam. So pause the video, think about what you think. Is this a chemical or a physical change? In this case, this would be an example of physical change. This is an example of a state change. So we've got our liquid water is being changed to a gas, steam. That's an example of a state change. State changes are always physical changes. Potassium chlorate decomposes. So what decomposes means is decomposes means breaks apart. So take a second, think about if you're breaking something apart, is it going to be a chemical change or a physical change? Potassium chlorate decomposing, this one's actually a bit of a tricky one. So based on what you know in grade 9 with this word decompose, I would go ahead and I would say that's a physical change. This is something that we're actually going to look closer at in grade 10, and you're going to see that when things decompose, it actually might be an example of a chemical change because you're forming new substances. So this one would be one that I'd put on hold for now. If you had said physical change because you saw the word decompose, I'd take it in grade 9. In grade 10, you're actually going to learn that this is more of a chemical change. Potassium chloride and oxygen gas are going to react. We're actually going to skip that one for now because, again, that's something that we're going to talk about a little bit more in grade 10. Last thing I do want to talk about, though, is iron rust. So I want you to think about what rust might look like. Pause the video and think about, is this a chemical change or a physical change? Iron rusting in this case is actually an example of a chemical change. Anytime you see the word rust, it's a chemical change. You're seeing a new unexpected color be produced. So for rust, I don't know if you've seen rust color before, but it's kind of that browny gray. So you're taking a metal and that metal is reacting with oxygen to produce a new browny gray color. That's a color change. So it is an example of a chemical change. Last one, ice melts. So if ice melts, is this an example of a physical change or a chemical change? I really hope you said physical because, again, this is an example of a state change. So it's really important to be able to classify things as chemical or physical changes. So there is going to be another practice worksheet for you available. I want you to try to identify chemical changes and physical changes, and then I'll post the answers for that as well too. All right, next up, we're going to be talking about different properties. We'll see you soon.